In today's question, we have 13 marks worth of parametric equations. Let's not hang around, let's jump straight in. So for part A, we are being asked to find an expression for dy dx in terms of t. And what you need to know is that the derivative is dy dx, but both of these functions are in terms of t. So you need to know that dy dx is equal to dy dt divided by dx dt, like this, because each of these we can find straight away. Let's do it. So to differentiate this, we need to use the chain rule to bring the 2 out to the front, and then we need to differentiate cos to get minus sine, like this. To differentiate this, we don't really need to use any special rules, it's just minus 2 sine t. So dy dx will be this minus 2 root 3 sine 2t divided by this, which is minus 2 sine t. Doesn't ask us to simplify it, but I'm going to simplify it because I noticed that these two minuses cancel out, these two 2's cancel out, and if you know your double angle formulas, sine 2t is equal to 2 sine t cos t, which the sine t's therefore cancel out. So the final expression for dy dx is 2 root 3 cos t. Shall we do part B? So before the actual question, it says the point P lies on C, which is the curve, where t equals 2 pi over 3. Whether I know what's coming next or not, I'm going to find the point P. Feels like it's going to be important. So t is equal to 2 pi by 3. Let's find what x is then. 2 cos of 2 pi by 3, which will be 2 times minus a half or minus 1. And then y is root 3 cos 2t, so 2 times 2 pi over 3, which would be equal to root 3 cos 4 pi over 3, which is root 3 times minus a half, which is minus root 3 over 2. So the coordinates of P are minus 1 and minus root 3 over 2, and that's going to be helpful later on, probably. Next, it says the line is normal to C at P. I see the word normal, I'm thinking I need to find what the derivative is. Luckily, we did that in part A. So at P, what's the derivative? 2 root 3 cos of t, which at P is 2 pi over 3, 2 root 3 times by minus a half, or minus root 3. So the derivative or gradient at the point P is minus root 3, but we're told that the line is normal to C at P. Therefore, we need to do the negative reciprocal, the neg rec, if you're cool like me. That's going to be 1 over root 3, like this. Now we need to show that the equation for line L is what's given. Well, this is just y minus y1 equals mx minus x1. Feel free to use y equals mx plus c as well, if you prefer. So y plus root 3 over 2 is equal to 1 over root 3, and then x plus 1. I'm doing pluses because both coordinates are negative. I'm going to times everything by root 3, like this, and then I'm going to times everything by 2, like this, and then I'm going to rearrange everything onto, looks like this side, so I'm going to minus 2 root 3y, and then I'm going to minus 3. I'm just writing that extra step just to show that I've definitely shown what they want me to show. 2x minus 2 root 3y minus 1, just checking it's exactly the same, and it is, so I'll put it in a box. And now for part C, whatever line we found in part B, Whatever that looks like, I have no idea. It intersects the curve again at a different point, which we're going to call Q. We need to find the coordinates of Q. Well, this line has x's and y's in it, and this is x and this is y for the parametric equations. So it's just a big simultaneous equation, but with three different things now. So I'm going to pop it in. So 2x, I'm going to write as 2 times 2 cos t. 2 root 3y, I'm going to write as this. Minus 1, I'm going to write as minus 1. Let's do a bit of expanding. So 4 cos t minus 6 cos 2t minus 1 equals 0. You've got to know your double angle identities here. There's 3 versions for cos 2t. There's only one that's going to be helpful though, because if we try and use this in terms of sine, what we're going to do with this cos. So we need to know that it's the cos version that we want, which is, if you memorized it, it's 2 cos squared t minus 1. If you haven't, use the compound angle formulas in the formula book to be able to derive it. If you can memorize it, I would highly recommend it. So to continue, expand these brackets. Let's see what we get. I'm going to get 12 cos squared t plus, no, minus 4 cos t minus 5 is equal to 0, which we're then going to put into brackets, which are the 5 and a 1. I spent far too long factorising that. So cos t will be 5 over 6, and cos t will be minus a half. If I think about the cos graph, it looks like this. From 0 to pi. I'm only doing it 0 to pi because that's what it says in the question up here. So when is this equal to minus a half? It's at this value here, 2 pi over 3. But this value was already used in the question here. That's the point P. So we know that the value of t that we're looking for is actually all the way up here at t is equal to cos to the minus 1 of 5 over 6, which I know is not going to be nice, but hopefully we'll be able to work with it. So it looks like x we'll be able to find quite nicely because it's just 2 cos t, which is just 2 lots of 5 over 6, or 5 over 3. Now if we find y, it'll be root 3 cos 2t. I think I'm just going to use the double angle formula. Again, the cos version, because we've got cos of t here, 5 over 6. So root 3, 2 lots, 5 over 6 squared is 25 over 36 minus 1, which is root 3, 25 over 18 minus 18 over 18, which is equal to 7 over 18 root 3. Therefore, what are the values of the coordinates of Q? They are 5 over 3, 7 over 18 root 3. Lovely question. Well, there you have it. That's another question complete. If you want a bit more practice, then try these 2 extra questions. If not, I'll see you in the next one.